Once upon a time, when a chessboard game was first created in India, the king offered the ancient legend and inventor any reward he would like. The inventor said, "My wish is very straightforward. I ask for 1 grain to be placed on the first square, which is on A1, 2 grains to be placed on the next square, which is on B1, and 4 grains to be placed on the third square, which is on C1, and so on, each time doubling." The king was bewildered by such a small ask, so he agreed. Now, let's work out how many total grains will he have on the 64th square. Notice, from the chessboard, the first square there is 1 grain, the second square there are 2 grains, the third square there are 4 grains, the fourth square there will be 8, the fifth square it will be 16. So there is a sequence. So in this sequence, notice that you are multiplying by 2 to get the next. When you multiply by the same common ratio, we call this sequence a geometric sequence. Also notice, in this sequence, the first term there is the same as 2 to the power of 0, it's 1. The second is the same as 2 to the power of 1, it's 2. The third is 2 to the power of 2. The fourth, 2 to the power of 3. The fifth, 2 to the power of 4, and so on. So I've completed this chessboard with powers of 2. So as you can see there, 2 to the power of 0, 2 to the power of 1, and so on until you get to the nth term. Also, you can calculate this value 2 to the power of 63 using the nth term of a geometric sequence. So the nth term is equal to A is the starting number, times R is the common ratio to the power of n, the total number of terms, minus 1. If you substitute in the values, you will get nth term is equal to 1 times R to the power of 64 minus 1, which gives you the nth term of 2 to the power of 63. This is what we have here. We do want to find the sum of the total grains on the chessboard. So we are going to use a geometric summation formula where A is the starting number, R is the common ratio, N is the number of terms. So we are going to have the total sum of 64 is equal to 1 bracket 1 minus 2 to the power of 64 over 1 minus 2. If you substitute the numbers in the calculator, you are going to get a huge astronomical sum of 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709 million, 551,615, which turned out to be much greater than what the king could provide.